Hello everyone, welcome back to Diksha Vedantu Foundation channel, and you are watching 99% in 99 days. Today is day 38, so another class of physics today, and I am going to discuss about the chapter electricity, and from the chapter electricity we will specifically discuss resistance and heating effect, okay, also power. Without any delay, let's start with today's chapter. So first let us look into the mind map of the chapter. We have already seen it yesterday, but if you have missed yesterday's class, let's look into it once more. Electric current and circuit was the first topic yesterday. Then electric potential and potential difference we have discussed. Circuit diagram also we have discussed. Then Ohm's law we have discussed. Right now, from Ohm's law, a new term that comes is called resistance and factors affecting resistance. Then resistance of a system of resistors, series connection and parallel connection. This is the part of this lecture. Then we will be discussing heating effect of the electric current, and then we will discuss about electric power. So if you are someone who is struggling with all these concepts, then go nowhere, stay with us till the end. So it will be going to be a not super long lecture, so don't worry, I will not take much of your time, but your exam preparation will be completed. Now let's start with the concept of resistance. So from Ohm's law, yesterday we have seen that what was Ohm's law? Ohm's law was V is proportional to I, right? V was proportional to I, and from there we have written V equals to I R. Right, so this term R was called resistance. So from Ohm's law we can write this R as V by I, right? So let's define resistance. R is the constant for the given metallic wire at a given temperature and is called its resistance. It is the property of the conductor to resist the flow of charges through it. For example, when I try to teach you something, you will say, sir, why are you teaching? I don't like to study, I don't like to do well in my future, right? So there is an inbuilt inherent resistance. Whenever your parents ask you to do something, you are very reluctant to do it on your own, right? So there is a resistance to it unless and until they ask you, okay, go watch cricket or go watch television or go watch some YouTube videos, then you have a full liberty and you can do whatever you want. Otherwise, if they ask you something which you don't like, then definitely you are someone who will resist it. That is the inherent property of everyone, including us human beings. So conductors are also like to be left alone. They don't want to do anything like you. They are also lazy, and if you try to pass current through it, they will try to resist that current. Right now, based on different types of conductors, there will be there is a variation of that resistance. We will see that in a while. And then in its SI unit is ohm and represented by the symbol this inverted omega. Okay, so this is the inverted omega. This is the symbol for resistance, and it is called ohm. Okay, ohm means it's by the name of the person who gave the Ohm's law. Okay, only the different thing is that this ohm, O is small letter. Okay, if you make this letter capital, then that becomes the name of the person. So you have seen in many cases whenever we are using units, okay, we are using either a symbol for that unit or we are using the name with a small letter. For example, Newton. Okay, if you write Newton with small letter, that becomes the unit of force. If you write the Newton with capital N, that becomes the name of the person, Isaac Newton. Right? So or if you just write capital N, that is fine. If you just write capital N, that means it is force. But if you write Newton with capital N, that is the name of the person. Similarly here as well, ohm is basically with small o represents the unit of resistance. Now, if the potential difference across two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm. That is 1 ohm is basically 1 volt per ampere. Okay, so 1 ohm is nothing but 1 volt per ampere. It is not a new unit. Only thing is since we use it a lot, so we have to assign a unit, a single unit, so that we can calculate it. So 1 ohm is basically 1 volt per ampere. Now let's see resistance of conductor. So factors affecting conductor. So there are three main factors that affects the resistance of a conductor. What are those? First of all, they are directly proportional to its length. So resistance is directly proportional to the length. More the length, higher is the resistance. Basically directly proportional means if you increase the length, resistance will also increase. Okay, what else? Inversely proportional to its area of cross section. Area of cross section means this is called area of cross section. Okay, if you see it from the side, whatever area it has, that is called the area of cross section, and it is inversely proportional. Inversely proportional means higher the cross sectional area, less will be the resistance. Inverse means more one quantity is, the other quantity is less, right? So that is called inversely proportional. I can give you one example of cars moving in a highway. Okay, so longer the path, you have to cross more number of cars, more number of vehicles on the road, so there will be more resistance. But if the road is very wide, wider the road, okay, more cars will travel in their respective lanes, and it will be easier for a driver to navigate through a wider road than a narrower road, narrower city traffic. That's why if you are sitting, you are watching from a city like Bangalore, where a lot of traffic congestion is happening because roads are narrower and a lot of vehicles are traveling, so resistance is very high. Now if you can somehow increase the width of the road, you can make the road wider, the resistance will decrease. Okay, you can decrease the resistance of the circuit. Similarly for resistance in conductor also, you can increase the resistance by making the conductor longer, more length, and you can decrease the resistance by making the cross sectional area higher. The third point is that it depends on the nature of the material. So nature of the material in the sense, if you are using, suppose you are using say copper. Copper has a very high conductivity compared to say for example iron. Both are metals, both are conductors, but copper is a super good conductor compared to iron. Similarly, if you are using platinum or if you are using gold or silver, they have a very high conductivity. Okay, but in our daily life we use copper because copper is not only a good conductor comparable to gold and silver, but also it is very cheap. That's why copper is used in our most of the day-to-day lives. Okay, aluminium is another good conductor, but aluminium is not as good conductor as copper. Okay, so aluminium is the second best choice in our daily life. The circuits that we use, they either use copper or use aluminium. Aluminium is much cheaper than copper, so aluminium products are a lot cheaper, but aluminium is not as good as copper, so aluminium products will have higher resistance. Okay, so that depends on the nature. So what material you are using, what substance, what element you are using to construct the circuit, that is very important. Now as I have said, resistance is directly proportional to length. So length is generally represented by the symbol L, letter L. So R is directly proportional. This is the symbol of proportionality. So R is proportional to L. Next, R is inversely proportional to the area. So R is inversely proportional means 1 by A. As I said, if you increase A, R should decrease. So inverse proportionality sign is 1 by A. Now if you combine these two, there is a law. If X is proportional to say Y and X is proportional to say Z, there is a law. Okay, you can combine these two proportionality and you can write that. First of all, you can write X is proportional to YZ. This is the first step. Okay, if one variable is proportional to one other variable independently, then you can write them. This obviously there are some condition that if X is proportional to Y when Z is constant, X is proportional to Z when Y is constant. So mathematically I am not going into too much detail, but you can say that okay, if these one variable X is proportional to Y as well as X is also proportional to Z, then you can write X is proportional to Y Z, and you can write this as X is equals to constant say K Y Z. This is the constant of proportionality. So whenever you are removing the sign proportional, you have to use a constant, as we have done in case of Ohm's law, and then from doing that we have arrived in the term resistance itself, right? So that term that we have used in Ohm's law, that was resistance. Now if resistance also has a proportionality constant, so and that proportionality constant is called rho. It is the resistivity of the material. Okay, in your textbook there is a list of material with different values of resistivity given. You can check that out, but I am not going into detail of that because that is not super important for your exam. So as we are focusing more on your exam preparation, so you have to remember that rho is called resistivity. Sometimes it is also called specific resistance. Okay, so rho is called resistivity of the material. Now resistivity can be defined, though even though that is not there, if you take, say, length is equal to 1 meter and area is equal to 1, say, meter square. I am taking SI unit. Then resistance of that wire will be rho. L is 1, area is also 1. Then you can say resistance of that wire itself is the rho. So resistance equals to rho. So rho is basically the resistance of unit length and unit cross sectional area. Okay, so whatever resistance of unit length and unit cross sectional area of a metal, of a conductor, that is the resistivity of that metal, right? This is a constant. It will not change because if you 1 meter and 1 unit length will not change, right? Unit length will remain same, so resistivity will remain same, and its unit is resistivity's unit is ohm meter. In SI unit, resistivity's unit is ohm meter. Okay, both resistance and resistivity of a material vary with temperature. Very, very important thing that you should know, that resistance and resistivity, even though I am saying it is constant, they are not constant with temperature. Okay, they are constant if you keep the temperature constant, then rho is constant. Resistance you can change by changing the length, you can change by changing the cross sectional area, but resistivity will remain same. But resistivity is not same if you change the temperature. So that was the first condition of Ohm's law. Remember, if temperature and other physical conditions remain same. So if the resistance as well as resistivity changes due to the temperature, as you increase the temperature, resistivity generally increases and resistance also increases. There are few exceptions as well, but that we are not going to discuss right now, maybe in future some other video. Now, if you are someone who also has like a resistance and you are thinking too much that you are taking too much stress about your future, that what should I do in future, what will be my goal, what should I do in future, then, and if you are not finding a way, we are presenting you Diksha Scholastic Aptitude Test, DSAT, which is happening across all the Diksha campuses every Sunday. What you have to do, you have to fill this form. The link of this is given in the description. What you will get in this, you will get a 1 hour lecture and a doubt clearing session. Based on that lecture, how much you can remember, how much you can understand, how much you can apply, there will be a test, aptitude test, okay, from that particular lecture. Now based on the qualities I mentioned, you score some marks, and based on that marks there will be a one-on-one counseling for you. Okay, suppose you are very good at application, okay, you are very good at understanding, then based on those results the counselor will guide you that okay, you are ready to take up on a difficult journey of JEE or NEET or KSET. You should focus your career on these 3 exams so that you can find the perfect future for you. Okay, so all the parents who are watching this video, I request you, don't wait, fill up this form to secure a bright future for your kid. Right, now let's continue with our lecture. Now we are going to discuss about resistance of the resistance of system of resistors. First, obviously, resistance in series. So what is the series connection? Series connection is when one resistor ends, another resistor starts. Okay, series resistor is basically when you can draw a system of resistors one by another. So one resistor is, suppose this resistor ends here, you are starting the second resistor from the same point. okay, and the third resistor again from the same point, then again the fourth resistor again, like that. So you can combine as many as possible resistors in series. For our easiness of our derivation, we will keep this to only 3 resistances. The derivation is slightly important, okay, and obviously application is very important, but sometimes they might ask you to derive the relationship as well, so don't miss this as well. So first we will do what is constant in case of series resistance, that we have to understand. As long as you understand this, and in the next part when we are doing parallel combination, what is constant in parallel combination, what is constant in series combination, your life will be very easy. So as you can see, this is a battery, okay, and the battery is sending current through this combination, okay. Now whatever current is exiting this battery, say current I is exiting this battery, okay, the same current will have to go through this wire as well, because there is no other path available. Now when it is reaching this ammeter, it is showing that the current in the circuit is I. Maybe I can be 5, 4, 3, 2, 1. So the students find it's difficult to correlate between values and variables, okay. Especially I have seen students, because in physics we are using variables a lot rather than values. Values we will use in specific cases, but other than that, for theory portions we mostly use variables, and students find it difficult that what will be the answer. So you can, in your head, you can imagine I may be a 2 ampere, I can be 2 ampere, I can be 20 ampere, I can be 50 ampere, but in your head put the values, for example say 2 ampere. The same current is passing here because there is no other path. Now the current is entering the resistance R1 is I. The same current should exit the resistance R1 as well, because there is no other path available. Now here as well, the current will enter, same current will enter R2, same current will enter R3 as well. So all three resistances have the same current. So in this case, in case of series connection, the resistance the current is constant. Current in the circuit is constant. Each and every component is receiving the current I, except this voltmeter. Voltmeter is connected in parallel. It does not consume any current. Ideal voltmeter does not consume any current. We assuming this is an ideal voltmeter, it does not consume any current, okay. It is only measuring the voltage. Now when all of them are connected in series, now what is the individual voltages across these resistances? So for that, what we have to do, we have to go back to our Ohm's law formula. So voltage was equals to, if you remember, if the current in suppose this is R1, the current is I, then voltage across this, say V1. Then from Ohm's law we know that voltage across any resistance V1 equals to I R, in this case IR1. Why R1? Because resistance is R1 in this case, right? So voltage across R1 can be written as V1 equals to I R1. Similarly, voltage across R2, say V2, will be equals to IR2, and voltage across resistance 3 will be IR3, right? So these are the individual voltages across these resistors, right? So individual voltages across this is V1, this is V2, and across this is V3, right? So these are the individual voltages. Now if you measure the individual voltages and add them, then by the conservation of energy, you should get the same voltage that you have applied. You should get the same voltage that you have applied as a source. So whatever source is sending, whatever voltage the source has, the same voltage should be applied across the resistances. So total voltage should be equals to V, that is V equals to V1 plus V2 plus V3, right? This is the equivalent total voltage. Now here we have to define a new thing. What we have to define? We have to define something called an equivalent circuit. What is an equivalent circuit? Equivalent circuit is basically if you replace all the resistors in the circuit by a single resistor. If you replace all the resistors in the circuit, no matter how they are combined, into a single resistance, you should remember that the equivalent circuit always remains the same. Okay, then you should get the same circuit. Okay, voltage V, current in the circuit, current will remain same, and we will say this resistance is Req. EQ stands for equivalent. Okay, so equivalent resistance, voltage drop across this resistor will be same as the combination of all the resistances, that is in this case V. So V will be the resistor voltage drop across this. So V, in this case we can say V is basically equals to I R EQ. Right? Equivalent is basically you take all the resistances connected in the circuit, replace it with only one resistance. It can be series, it can be parallel, it can be combination of those, it can be very complicated circuit. No matter how they are connected, you can always combine all the resistances and find this Req. That is the goal of solving any resistance related problems. Okay, not only in this class, in your PU2 as well. When you learn this chapter again, current electricity, there is a chapter current electricity in PU2 as well, very important chapter. Or your class 12th, those who are from CBSE background, they may not understand what is PU2. So class 12, PU2 is basically class 12th. So in class 12th you will learn about this chapter, this concept again. Okay, that time you will be solving much more complicated and difficult circuit, not super simple circuit. Okay, now so V is equal to V1 plus V2 plus V3. Now what is V? If you construct the equivalent circuit, V is nothing but IREQ. So V is equals to IREQ. And what is V1? Just put these values, I R1 plus I R2 plus I R3. Now if you take I common from both sides, so I REQ is equal to I equal times R1 plus R2 plus R3. Okay, so I is common both sides, so I will cancel. Or you can write R equivalent is basically R1 plus R2 plus R3. Okay, so this is the equivalent resistance. So when few resistances are connected in series, their equivalent resistance is basically adding them. So what will be the equivalent resistance if you connect say 3 ohm, 5 ohm, 4 ohm, 7 ohm in series? You just need to add them one after another. Okay, and you will get plus plus plus, so it will be 19 ohm. Okay, so that will be the answer. So you have to know that when you are saying that resistances are connected in series, that means the total resistance, the equivalent resistance of the circuit is basically addition of all of them. Okay, in some cases series is directly not asked, it is the easiest derivation. Okay, parallel sometimes is some more important because that is slightly tricky, but that is also I will make sure that you understand and you can solve that as well. Now let's move into the, as I said, resistances in parallel. In case of parallel, okay, all the resistors, if you see, they have a common starting point and they have a common ending point. So the starting point and the ending point are common. Okay, in case of series, one was ending, another one was starting. Right? In this case, all the resistors have a common starting point, and all the resistors are culminating at a same point. So common starting point, common ending point. So three resistors connected like this. Now what you have to do, you have to find the equivalent resistance. That is our goal. And equivalent circuit will always look the same, no matter what type of connection you are using. The equivalent circuit will always remains the same, and equivalent circuit equation will also remain the same. no matter whatever type of connection you are using, series, parallel, combination, the equivalent circuit will always have the same formula, V is equal to I R eq. Here I is the total current in the circuit. Okay, V is the voltage that you have supplied. Now, in case of series connection, we remember that current was same, right? Now, is the current same in all the resistors in this case? So current was I current was coming through this. Okay, I current was coming through this resistor. Now here at the starting point, current has 3 paths. In that case, there was no path, only one path was available. That's why all the resistances having same current. Now at this point X, we have 3 available paths. So some current, say I1, will go through this path. Some will say, no, I will not go in that path, I want to go to this path, I2. And the remaining will say, okay, there is a last path available, I will go through this path. After but the input current was I. Okay, input current was I, current divided into 3 parts, and once they come out, okay, I1, I2, I3, they will come out as it is, and then once they meet, okay, they will discuss what happened in their path. Okay, you know, my path was very smooth, I came completely unharmed. Other one say, no, my path was full bumpy, it has a lot of rocks. Someone will say, my path was beautiful, I have seen a lot of birds, lot of animals. Okay, so they will discuss about them, but when they come out, they will have the same current I, because you remember that whenever a current exits a battery, the same current should come back to the battery. Okay, that is one of the conservation principle. Okay, conservation of energy, conservation of charge. We will learn that in your future class, conservation of charge principle. You can identify this as a partly conservation of energy for now. Okay, but actually it is related to conservation of charge. We will see that in our second PU, as I mentioned, class 12th. But you should remember always that whatever current exits a battery, the same current has to come back to the battery in the other end. So if the I current exiting from the positive end, I current should come back to the negative end as well. Okay, so if your father gave you 10 rupees and say, okay, buy this, buy a pencil for me, you buy a pencil and an eraser and a sharpener, and at the end you got 2 rupees extra, you buy a chocolate for that, and in the end you will say, your father will say, what happened to the extra 2 rupees? You have to tell him that, okay, I ate one chocolate, right? So similarly here also every account has to be every expenses has to be accounted for. So if I current is exiting, I current has to enter into the circuit. Okay, there is no space for 2 rupees chocolate in this case. Now, so I1 current is passing through resistance R1. So I2 current is passing through R2, I3 current is passing through R3. Now if you apply a voltmeter, okay, between these 2 points, you will see that all the resistors are connected with this voltmeter. Voltmeter cannot show 3 different readings. Very complicated thing, because all the 3 resistors are connected, and I can simply connect the voltmeter like this. Now what the voltmeter will show? Will the voltmeter show different readings for different resistances? Actually no, because they are connected in parallel, their starting point and their ending point is same, so they are being kept at a same voltage. Okay, their potential difference will be same. Potential difference does not depend on how the resistances are connected. As long as you are fixing a voltmeter between 2 points, the voltage will remain constant. So voltage remain constant means in this case, so in case of series combination, we have seen current was constant by default. But in this case, because they are connected in parallel, I can connect a voltmeter like this. So voltage has to be same across all 3 resistances. So what is that constant voltage? So constant voltage, say V, because this V will has to be equal to that of the supplied voltage. There is no other voltage source. There is no way the other voltage can be anywhere, the voltage can be taken away. So voltage, whatever voltage you applied, the same voltage has to be here for all 3 resistances. So for resistance R1, I can say V is equal to I1 R1. for volt, or I can say I1 is equal to V divided by R1. Similarly, V is equal to I2 R2 for resistance R2. For resistance, this is number 1, resistance number 2. Okay, again I can write I2 equals to V by R2. Similarly, for resistance 3, I can write directly I3 equals to V by R3. Right, so this is the current. I have calculated the individual current. Voltage was same, so I just needed to find the current. Why? Because I know that I current was separated into 3 currents and then they again merged, and I got the same current I. So I is basically the total current in the circuit is basically equals to I1 plus I2 plus I3. Right, this is how the current separated. Now let's put the values. Now from this circuit, from this equivalent part, I can write I is equals to R equivalent, V by I R equivalent. Okay, from this, again as I said, this equation will remain unchanged for any circuit. Okay, how you are treating it, that will change. For example, in the previous case we directly inputted the value of V. In this case we are using the value of I. So V divided by R equivalent equals to I1 is V by R1 plus V by R2 plus V by R3. Now take V common. So V by R equivalent equals to V is common, 1 by R1 plus 1 by R2 plus 1 by R3. Now this V cancels, so we get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the parallel combination of resistances. Now as I said, this combination is not restricted for 3 resistances. It can be 2 resistors, it can be 5 resistors, it can be 100 resistors. No matter whatever, how many number of resistances are connected in parallel, you have to add everything like this. But there is a shortcut for 2 resistances in parallel. If 2 resistances, say R1 and R2, are connected in parallel, there is a shortcut formula. Okay, this is a special shortcut formula for 2 resistances connected in parallel. Okay, remember that here you are calculating 1 by. Okay, so you have to add them, then again take a reciprocal to find the actual value. Right, but if 2 resistances are connected in parallel, then you can directly find the equivalent resistance by using this formula, R1 R2 by R1 plus R2. This formula is very handy to solve numerical questions in a short time. So you should remember this formula. Okay, you can apply this formula for 2 resistances in parallel. You cannot apply this if more than 2 resistances are connected, but for 2 resistances connected in parallel, you can easily apply this formula. Now let's move on to a problem. Here we are solving a series connection problem. We will be solving more numerical problems in our tomorrow session, in our PYQ session, but I want to just give you an idea how to solve a numerical question. An electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 volt battery. Calculate A, the total resistance of the circuit, B, the current through the circuit, and C, the potential difference across the electric lamp of the conductor. Okay, electric lamp and the conductor, so both you have to calculate. So first of all, this resistance was given 4 ohm, this resistance was given 20 ohm. Okay, and as you can see how they are connected. They are connected, so if you see the current that is passing, you can do it by 2 ways. Okay, first of all you can check. Now we know that in series connection current is same, so you can check if the current is same or not. So current I is entering here, the same current is exiting, the same current is entering the lamp, and same current is exiting. So from the comparison of current, I can easily say that both of them are connected in series. So in series combination, the equivalent resistance part A, okay, equivalent resistance is basically simply adding them, 4 plus 20 that is 24 ohm. You must use the unit, don't forget about the unit. Okay, so 24 ohm is the equivalent resistance in this case. Now part B is what? Calculate the current in the circuit. What is the current? To calculate current, we will use the equivalent circuit theory now. Voltage is given, equivalent resistance is calculated. So V is equal to I R eq. That's why we are interested to calculate equivalent resistance. You cannot do it without knowing the equivalent resistance. That will be very long, very hard. But if you know the equivalent resistance, you can simply calculate it by applying this formula. So from here you can calculate I is equal to V by R eq. So V is 6 volts and R eq is 24. 4 6 are 24 ampere. Current will be, unit will be ampere. 1 by 4 ampere or 0.25 ampere. 1 by 4 is 0.25. Okay, or there is another unit of current. If you know the answer, mention in the comment below what will be the other unit of current that you can use it here. Okay, I will not tell that. That is not relevant. Even if you are not using it, you will get full marks. Next is part C, the potential difference across the electric lamp and the conductor. So what is the potential difference across the lamp? So potential difference across the lamp is basically resistance of the lamp and the current in the circuit. V is equal to IR, but because we are only considering lamp, so we will consider the resistance of the lamp only. So what is R lamp? Given that lamp is 20 ohm and current we have already calculated, 1 by 4, so it will be 5 volts. What will be the potential difference across the conductor or resistor? Okay, in this case R times I. What is R? R is 4 and current is 1 by 4, so 1 volt. So 5 volt and 1 volt are the answer for part C. So this is an easy question, 3 marks question. If you solve it step by step, you get full 3 marks, right? So problems are not super difficult if you know how to solve them. That is the main thing, right? Now next is heating effect of electric current, another important concept. So let's see. Consider a current I flowing through a resistor. So we have a resistor in a circuit, part of the circuit, a current I is flowing through this. Okay, resistor resistance R, let the potential difference across it, the potential difference across it V. Okay, and we know that V is equal to IR. That is obviously, as soon as I write this equation, you should remember that Ohm's law, V is equal to IR. Okay, V is, even though V is given or not given does not matter. If I and R are given, you can calculate V using this formula, right? Now, the power consumed by the resistor is given by, so power, which is basically work done to take the charge from one point to another, is basically given by P is equal to V times I. This is the formula for power. You have to remember that power is basically given by V times R. Sometimes it is also power is P is equal to VI, Y, Vodafone Idea, right? Even though that is not super popular nowadays. Okay, there was a time when Vodafone and Idea itself, they both were very powerful. So that's why Vodafone Idea, now they have combined together to give you power, right? So VI is the formula for power. You can remember it like this. Okay, and V is basically IR, so you can write this as I square R. Okay, again in terms of V, you can write this as V square by R. These are the formulas for power. Now this power is not sufficient. Okay, power is what is consumed in the circuit, but most important is what happens to this consumed power. So if I switch on the light, okay, partly it will convert into light and remaining it will be converted into something else. What that something else? That something else is heat. Okay, now if it is simply a resistor, entire energy that is consumed by the resistor, it will be converted into heat. There is nothing else to do. In case of a lamp, okay, the part of this power is always consumed by this amount. Heat energy is not always, but it is only for resistors and some specifically designed electrical component. We will see that where we are using this heat. So it is mostly converted into heat. That's why when you touch a hot lamp, or even if you are using your mobile phone for a long time, it becomes hot. Why? Because the power that your mobile phone is consuming is converted into heat energy. By default, heat energy will always be produced. Okay, no matter what. So what is the formula for that heat energy? Heat energy is given by power times how long you are using it. So more you use your mobile phone, it will become more hot. Okay, so you can say this is equal to VIT. Heat is vitamin. Okay, heat is a kind of vitamin D, right? If you stand in sun for some time, it will produce vitamin D. So that's how you can remember. So heat is basically VIT. Also, most commonly used formula is I square RT. Okay, I square RT, just multiply T in this equation, or you multiply T in this equation, V square T by R. All are equation for heat energy. Okay, so whenever you are using a device, okay, it becomes hot because current is flowing through it and there is a voltage difference, and if you switch it on for some time longer, it is on, more heat it will generate. Okay, you can check with if you touch a hot a lamp, if you are using the lamp for some time, if you touch it, you will feel the heat. Don't do it recklessly, because that might burn your finger. So do it with a caution. Next is electric power. Let's see, electric power we have already discussed, but the electric power that we consume in our home, okay, they are not generally expressed. The power for, in this case, in this formula, power unit is joules. Okay, power is basically power is watt. Okay, power consumed by a device is basically watt, but in our domestic purposes this unit is not sufficient. Okay, this gives you how much power it is burning per second, joule per second. But when we pay the electric charges, okay, when you pay the electric charges in our household bill, if you have checked your electricity bill, okay, you will see that there is a thing called unit consumed. Unit consumed. What is the meaning of this unit? One unit, and also this is not actually electric power, this is an electric energy. That is the beauty of it. The electric power that we say we have used this much power, actually that is electric energy. Okay, power is per second. So if you are using a high power for 1 second, does not mean your electric bill will be higher. If you consume more energy, so electric power, the conventional electric power that we use in our domestic circuit, that is basically a unit of energy. What is that? That is kilowatt hour. Okay, kilowatt hour, and 1 kilowatt hour means 1000 watt. Kilowatt, kilo means 1000, right? So kilo means 1000, kilogram means 1000 grams. Similarly, kilowatt means 1000 watt. And 1 hour means if you switch on 1 kilowatt device for 1 hour, how much power it will consume, that is called kilowatt hour. Okay, every device, every electrical device, they have a power rating. You can check your fridge, you can check your AC, you can check your TV as well. Okay, everything has a power rating. So the power rating is basically 1000 watt for 1 kilowatt, and 3600 is the second. So for if you run that device for 1 hour, how much power it will consume, that is mentioned in the label. Okay, so 1000 watt times 3600 second is the 1 kilowatt, and that is the 1 unit. So if you see in your electric bill, 100 units for, if you have used 100 units, your electric bill is say 1000 rupees. Why so? Because 100 unit is not only about 100, this is about this much energy. Let's see how much energy it is. So 1000 watt times 3600 second is basically 3.6 times 10 to the power of 6 watt second. So this is 10 to the power of 3. This you take 1 point here, that also becomes 10 to the power of 3. So 10 to the power of 3, 10 to the power of 3 becomes 10 to the power of 6. So 3.6 times 10 to the power of 6 watt second, right? Or 3.6 times 10 to the power of 6 joule. Joule is the unit of energy. So in our domestic power supply, whenever you are using 1 unit, that is basically how much joule you have consumed. So 100, if you consume 100 units, okay, that means 100 times 3.6 times 10 to the power of 6 joules unit you have energy you have spent. That is a huge energy, right? So this is a very high amount of energy that you have spent, right? Now let's see one problem. An electric refrigerator rated 400 watt operates 8 hours a day. Okay, so the electric refrigerator is rated 400 watt and it is operating for 8 hours per day. What is the cost of the energy to operate it for 30 days at rupees 10 per kilowatt hour? So that is average power consumed. So first of all, you have to calculate the total energy consumed. Okay, total energy consumed is per day. Energy consumed per day is 400 watt times 8 hour per day. This is the energy consumed in 1 day. What is that? 3200 watt hour per day, right? Or, but this is not sufficient. Watt hour is not the unit we want. We want the unit to be kilowatt. So you have to divide it by 1000. Okay, so divide by 1000, it will become 3.2. So that will be 3.2 kilowatt hour per day, right? So this is the energy bill, that so 3.2 units per day. So how much unit it will consume in 30 days? So energy consumed in a month will be 30 times 3.2 kilowatt hour. That is the total energy consumed. So it will be 96 kilowatt hour. So this much energy is consumed by that refrigerator per month. So what is the electric bill? So electric bill will be, okay, I am writing, tried to write RU, but somehow it is not happening. Let me write in terms of dollar only. This is the easier symbol, right? So this is the symbol for money. So how much money you are spending? You will be spending 96 times 10 rupees or 960 rupee. Okay, now this is fine. So 960 rupees you will spend to cover the expenses for this refrigerator alone. Okay, so this is a high maintenance refrigerator. It is spending a lot of money. So be careful. Okay, buy refrigerator that consumes less power. Okay, check before purchasing. Now if you are also want to jump into the future of your career without checking the level in it, so there we have a particular test for you, that is Diksha Scholastic Aptitude Test. I request all the parents and the students who are watching this that take your student for this beautiful opportunity, that what will be your future goal, what should be your focus about. The link of this is given in the description. You have to fill up this form, and once you have filled up this form, you will be invited to attend one of our Diksha Scholastic Aptitude Test centers. Okay, there you will be given a 60-minute lecture. Based on the lecture, also there will will be doubt clearing session if you have any doubts in the lecture. Okay, so the teacher will clear all the doubts, and after the doubt clearing session is over, there will be a aptitude test based on the lecture. Now how well you are performing in that aptitude test based on that lecture. Okay, how much you can remember, how much you can retain, how much you can develop on your own. So based on those qualities, the counselor, there will be one-on-one counseling available after the test is over. Okay, and the counselor will guide you for best possible course of action for you, whether you should choose JEE in future, or you should choose NEET in future, or you can choose KSET in future. So all the possibilities the teacher will guide you, or maybe they will tell you, okay, science is not for you, you should better prepare for commerce or arts. So every informed decision is better than any not informed decision. So I request you fill up this form and take a wise and decisive career step in your future. Okay, and if you liked our video, don't forget to give it a thumbs up and share it with your friends, and subscribe to our channel if you have not done yet. I'll be back with PYQs tomorrow. Till then, bye.